All right, so for this game, looks like we have yet another sequencing game. We have essentially 6 boxes that are going to be stacked, 1 through 6, so we can set it up accordingly. We have position 1 through 6. For the record, if you wanted to do this setup vertically just so that you can physically see it going bottom to top, that's not unreasonable. Personally, I prefer having the consistency of our standard kind of chart, and I'd prefer kind of just using that all the time. Kind of force of habit, but yeah, it's not unreasonable. You could kind of flip the chart 90 degrees and kind of do it across. That's entirely fair. Anyways, so from there, before we keep going, let's just kind of make sure that we have our basics down. 1 through 6 with the lowest box up to the highest. So that means that the low side is on this side and the high side is considered on that side. Now the elements themselves were a bit more limited here. We have G, R, and W. And it's worth noting, from the get-go, they don't actually commit to the idea that every single color has to be used. So as of right now, we might actually be missing colors entirely, and that's something that you do want to recognize when you have any kind of irregularity. So from there, let's take a look at the rules. So the first rule says that there are more reds than whites, so we have to have, I guess, R is more than W, which at this point now tells us that at the very least, we certainly have to have at least one red ball, right? Since we have to have more than the whites. Now, at this point, we don't necessarily have any whites at all, so it could be 0 whites and just 1 red, but at the very least, we definitely have a red. Next, second rule, there's a box containing a green that is lower than any red. So I guess we can say something like we have to have a green before any kind of red. So this one's a bit ambiguous as to how you might symbolize it, but what I'll do is I'll just circle the red to indicate that it's not just a red ball, it's just any red ball, and that's what this will mean to me. Now, this also does now tell me that there will be at least 1 green ball for sure, so I am now up to at least 1 green and at least 1 red. Next, lastly, there is a white ball in a box there is immediately below a green. So essentially, we have to have a W right below or before a green. So we have to have essentially a WG block somewhere, which first of all, now tells us that there's definitely going to be a W on the board, right? So that actually also helps with the numbers. Now we have to have at least 1 of each. Now, it's worth now considering, does this WG block have to be the same as this G? And it doesn't. Perhaps we could have another G on the board, right? So you could have a G before all the R's, and at a later stage, we could maybe have a WG there. Now, before we keep going, it's probably also worth revisiting the numbers a little bit, because we know that if there's at least 1 W now, then red, we would have to have at least 2 of them, right? So in fact, let's kind of keep tabs on this. We would have to have a minimum of 1, or yeah, at least 1 W, at least 2 reds, and I suppose at least 1 green. So maybe that's kind of worth recognizing. And I suppose that leaves us with 2 extras beyond that. Now, what could we? I suppose we could have 2 whites, couldn't we? Because if we do 2 whites, then we could have 3 reds, and then we would have just 1 green, and that still seems okay. So I guess that's not really quite limited. You know what? Let's go with this. So the questions themselves, number 18. If there are exactly 2 whites on the board, then which of the following could be a green? So if we have to have 2 whites, I suppose one of them is going to have to kind of buddy up with this green. And as we said, if we have 2 whites, then we have to have effectively 3 reds. And actually no more than 3 reds, because if we had 4 reds, then there would not be enough space for a green. So I guess that's something. But the 1 green, wait a minute, the 1 green that we have has to go before all of the reds. So where could we have that? I guess the latest that the green can go is in 3. And since it's going to have to buddy up with a W, the earliest it can go would be 2, right? We can do a WG in 1 and 2, or we can do a WG in 2 and 3. I suppose we can split scenarios just to kind of see how that would work, but I guess we don't have to. The question asks which of the following could be a green, and we just answered that question. It could go into either 2 or 3. Since 2 is not an option, the best answer for question number 18 is B. Next, number 19. If there are green balls in 5 and 6, well, I guess let's play that out. Since we didn't use this scenario, let's just get rid of that. There are greens in 5 and in 6. Now, at this stage, I suppose we still have to have at least one more because we need to have a green before any of the reds, and we're definitely going to have some reds. And I suppose the WG block, though, that could still be a little bit flexible. But wait a minute, if we have one more green and we have to have a white, and that's everything, right? And 2 reds. So there's just going to be 1 white in this game right now, and there's going to be 2 reds, and there's going to be just 1 green extra remaining. Now, in terms of the reds, I suppose we have a little bit of flexibility here because the WG block potentially could go into 4 and 5, and then we could have GRR, or we can do WG in 1 and 2, and we can do RR in 3 and 4. You know what? Let's see. Maybe we have enough information. The question asks, which of the following could happen? Answer choice A, could we have reds in 1 and 4? And no, you can never have reds in 1 because the reds have to follow at least 1 green. Answer choice B, could we do reds in 2 and 4? And no, because if we do reds in 2 and 4, there would be no room for the WG block. Answer choice C, could we do a white in 1? And that I think we could, right? We could do a WG with the reds in 3 and 4. That seems very much plausible. Just in case, can we do a white in 2? And no, because if we put a white in 2, then G would have to go into 3 for the WG block, but then one of the reds would go before the green, and that's not going to work. So D is out. Answer choice E, could we do a white in 3? And again, no, for that to happen, you would have to have a WG block in 3 and 4, and then the reds are going to go prior, which isn't going to work. So the best answer to question number 19 is C. Next, number 20 is global, number 21 is global. Let's take a look at question 22. If there are red balls in 2 and 3, which of the following? Well, okay, so if we have reds in 2 and 3, what does that tell us? Well, first of all, obviously we have to have the G before the reds. So G is going to lock into number 1. And I suppose we still have to have a WG somewhere, right? So we'll have to have a WG block in between 4, 5, and 6. Now, we actually would now be limited to just 1 white ball in total now because we still have to have a WG block here. If we had another W, then we would have 2 Ws, but we would have 2 reds, and they would equal. We can't do that. We have to have more reds than whites. So we can't have any more whites. But I suppose we could have 2 greens. We could do something like WGG, for example, and nothing would break. Or we could have an extra red as well. So we can do something like WGR or some combination thereof. So we have a bit of flexibility. We just know that we'll have to have a WG block somewhere between these 3. And then we'll either have an extra R or an extra G. So to the question asks which one now could be true. A, there's a red in 1, and definitely not because that's green. B, there's a white in 1. No, same thing, it's green. Next, there's a green in 4. And maybe if we run a G over here, we could still fit a WG in 5 and 6. I think we might be able to swing that. Let's hold on to C. Answer choice D, can we do an R in 5? And no, if we put an R over here, then that would split the WG block between 4 and 6. That's not going to work. Answer choice E, can we do a white in 6? No, because if we put a white over here, then you'll have to have a WG block separately, which I guess could go into 4 and 5, but then you would have 2 whites, which we can't do right now. So the best answer for question 22 is C. Next, question 23. If boxes 2, 3, and 4 all have the same color, well, okay, so these guys over here, 2, 3, and 4, all of these are the same color. Well, obviously, I guess they can't be white, right? Because we know that we can't have 3 whites because that would require having 4 reds, and we certainly can't do that. But I guess they could all be reds. If these are all reds, then the green goes here, and I suppose W and G then can go 5, 6. Or could they all be greens? And yeah, maybe if we put them all greens, then you can have WG in 1 and 2, and then the reds could go over here. I think that's actually legit either way. You know what? Let's just split these out. We can do either triple reds or we can do triple greens. Now, top scenario, if they're triple reds, then G has to go before any of the reds. And then for the WG block, that'll just go into 5 and 6. And then in the bottom scenario, if we have triple Gs, the 2 reds can't go before the Gs, so the 2 reds will go into 5 and 6, and then the WG block will go into 1 and 2. So let's see what we can do. The question now asks what must be true. Answer choice A. Exactly 2 of the boxes are green, and that could be, but it doesn't have to. Over here we could have had 3 greens, so A is out. Next, exactly 3 are green. Again, that doesn't have to be. We could have had just 2 greens, so that's also out. C, exactly 3 are red. Again, we could, but we could also have just 2 reds, so that's out. D, exactly 1 has white. Oh, yeah, there it is. So no matter what we do, white, there's just 1, and over here, white, there's just 1. So either way, you're going to have exactly 1 white ball. So the best answer here is D for question 23. Just in case exactly 2 have a white ball, and no, that's outright false. We actually can't have 2 whites in this scenario. Next, back to the globals. So question number 20. The ball in which of these boxes must be the same color as at least one of the other balls? So this is a bit of a messy question, but this is asking for which one of these boxes is the color going to have to be the same as another box? Or really, this is kind of a roundabout way of asking, which of these boxes cannot be unique? We're looking for a box that can't have the only color of that sort, something that has to have the same color as some other box. Now, we do have a little bit of history that can help us here, because we know that in this scenario, 5 was unique, so 5 obviously doesn't have to be the same color as something else. And in this case, 1 was unique, so 1 also obviously doesn't have to be the same color as something else. So 1's not an option, but 5 was, so that at least helps get rid of answer choice D. Now from there, this probably gets a bit messier, but you know, let's just kind of go one by one. Answer choice A. Could box number 2 be completely unique? And arguably, I mean, there's not that much restriction here. So if we just did something like a WG block in 1 and 2, couldn't we just shove reds into the rest of them? And that would easily be okay. So 2 could be, for example, unique as the only G on the board. So answer choice A doesn't have to be like another box. Next, what about box number 3? And again, in fact, same thing. Couldn't we do something like WG in 1, 2, and 3? So that would be 2 whites, and then you would have 3 reds across 4, 5, and 6. That seems like it could easily happen. So answer choice B, 3 could have been unique. It doesn't have to be the same color as another box. Answer choice C, box number 4. Could this guy over here be unique? Well, actually, if we look at this scenario, arguably, couldn't we have put a white into number 4 as the only white? And then let's actually plug that in. We could put a white over here, and then the rest, we could do something like G, R, R. This doesn't break any rules, does it? Because we have a WG block and a G is before all of the R's, and we have more R's than whites. So that could happen. So 4 could have been unique. We can get rid of answer choice C, and I suppose that just leaves us with answer choice E. Could number 6 be unique? And actually, no, I suppose it couldn't. So here's the thing, no matter what you do, no matter what color you put in here, if this is red, then obviously there's going to be another red, so it's not going to be unique. If this was white, however, then you're still going to need a WG block somewhere, so it's not going to be the only white. And if this was green, then you're still going to have another green before all the reds, so that's not going to be the only green. No matter what color you put into number 6, there it is, it's going to have to be the same color as some other box. So the best answer to question number 20 is E. Next, number 21. Lastly, which of the following must be true? Let's take a look. Answer choice A. There is a green that is lower than 4. Actually, that feels kind of right, doesn't it? Because we know that we have to carry a green before all of the reds. So I guess the question becomes, could we have no greens below 4? And no, because if we put a green 4 as the earliest, then your 2 reds are going to be stuck in 5 and 6. But then what's going to go into 1, 2, and 3 if we don't have greens and if we don't have reds there? They're all going to be whites, and we certainly can't have 3 whites back there, can we? Which means, yeah, we can't start the greens on number 4. That would break. So that would have to be true. There has to be a green ball earlier than the fourth box. The best answer to question number 21 is conveniently A. Just in case, let's take a quick look at the rest of them. Answer choice B, there is a green that is higher than 4. Does that have to be true? And no, in this scenario, we had no greens higher than 4, so B doesn't have to be true. C, there is a red that is lower than 4. And actually the same scenario, we had no reds among the first 3 here, so we don't have to have a red that's lower than 4. Answer choice D, there is a red that is higher than 4. And no, in this scenario, we had 0 reds in 5 and 6. We don't have to have a red that is higher than 4. And E, there is a white that is lower than 4. And also no, because in this scenario, once again, we had no whites down here. The only white was over here, so we don't have to have a white that is lower than 4. Best answer, once again, is A.